Hello everyone. Welcome back to the fourth year of Hewlett-Packard's Lab podcast From Research to Reality. My name is Dan Milojcic and I have great honor and pleasure to welcome back Suparna Bhattacharya. Hello Suparna.
Yeah, hi Vijay. It's really good to be here in person.
Yeah, Suparna is here in person, but there's one more important reason why we have her. Suparna just got promoted to HPE Fellow and VP. Congratulations, Suparna.
Thank you.
Can you explain to our audience what does it mean, HP Fellow and VP, and what does it mean personally to you?
So HPE Fellows are supposed to be pioneers in their field in some respect and have a responsibility of helping shape the future for HPE with their contributions and also have an impact on the industry. For me personally, it means a lot. I'm actually honored to be entrusted with this responsibility, and I'm also very excited because it means this is a recognition of the work that we've been doing with my wonderful colleagues here in labs and across HPE on AI and data. It also has a significance for me because I always had this dream of making a foundational contribution to technology. But back when I started my career in India, most people around me didn't believe that you could actually grow in a technical career and pursue really impactful innovation while staying back in India. That's not the case now. But that's why it's kind of really special for me, because I wanted to make it possible to something so that other people can also feel that they can do the same.
Very nice. So it's not only about you, but about all these people in India, and especially ladies out of India who can follow your example. But tell us a little bit more. What are the requirements? It's not easy, obviously. It's really hard to become. There are few fellows. So what does it take to become a fellow?
Yeah, it is hard. It's hard in many respects, but I think it's really a culmination of a career-long thing. It's not like a one-point thing, I feel. And it involves maybe having contributions, not just in your area, sustained contributions in your area for sure, but the big challenge is when you say a pioneer, it means, it feels very nice. Okay, you're being the first to do something, but it actually means getting bruised a lot in trying to carve out new paths, and it requires taking a lot of initiative beyond one's own group. HPE Fellow requires contributions across multiple business units, working with people outside HPE. It also involves things like looking at what is of strategic relevance, being able to look at discontinuities sometimes going wrong, but then figuring out how you find the way forward. So I think all of these things really take time to build. It takes a lot of collaboration. It takes having wonderful colleagues and great people around you. I think just fortunate to have that here.
But these are primarily technical and business contributions, true? Not managerial.
Yes, that is true. That is true. Yeah.
So we spoke about it in abstract. So what specifically were your contributions that deserve such an excellent promotion?
So maybe I'll talk a little bit about so as I said, this work at the AI intersection of AI and data. So it's been a kind of a culmination of thinking of what we could do, and I work in system software, so I always think in terms of how could we build system software that would be suitable for the applications that are emerging and the next generation applications, the applications which will be used by most people in the world. And AI today, most of the applications are now slowly being driven by AI. And I was working on storage, and I was really looking at the real problem that people have in developing AI. And one of the big problems is getting good data to AI and figuring out how to use that data to get to AI models. So my work on the self-learning data foundation for AI and innovation project data map, for example, are instances of some of the things I did in that area. And the precursor to that, I worked on something called meaning-aware storage in the storage CTO. So I think some of those were the contributions.
And based on your experience, very positive experience, what would you advise your colleagues, male and female equally? How can they become your successors down your path?
I think everybody would carve their unique path. I think that's what I feel when I speak to people. So everybody has their own perspective and point of view, and maybe because of the background you're coming from, maybe there is a unique angle that bring. But I think it takes a lot of work to make that unique angle shine. It takes a lot of work to actually build new IP, show it, prove it out. And one of the big things I think is anything that is big or significant cannot be done in isolation. Many times as engineers, we love to work on problems and we love to solve those problems, but this is about making that impact, and that requires, for me personally, for example, as an introvert, it's hard for me to go out and talk to people, go out and work with people from other groups, but it's always very exciting. And these possibilities for innovation come by working, with different teams. So I would also say the message that Antonio gave me right after this promotion, when I had a one-on-one with him, he said, be bold and try to make sure your work actually can impact, across HPE, have an impact across HPE. And so I think that's what I would also recommend.
That's very nice. Very nice. But to paraphrase what you said earlier, I learned two things from you. One is that, according to book, and I know you like to read books, it's discover your strengths. Play to your strength, patch up the weaknesses. Everyone's different. That's one thing. And the other thing I learned from you was that it is individual promotion for individual, but still there needs to be some team that followed you and helped you.
Yeah.
So let's go a little bit deeper, given that it's technical promotion for technical path, technical career path. Can you speak a little bit more about Data Foundation? What is it? Why it is important? How did you do it? Where's the future of it, etc.?
Yeah, sure. Yeah. So as I was saying, there is this little bit of a gap between the way we think of data at an infrastructure layer and the way data is required at AI applications. For example, if you are, say, building a model for analyzing some image data, or maybe you're building a model for predicting fraud, or you're building a model for finding, predicting power consumption. In all of these cases, you kind of build a model out of some data sources, and really it's the process of getting that right data and the process of combining that properly that's really crucial. And you don't get much help on that part from the system. There's a lot of literature on AI models, but there's not enough help on that side. So a key idea of the Data Foundation was to build this intermediate layer that can tap into what people are doing in AI applications and AI workflows and how they're succeeding. And that's kind of where this issue of data lineage comes in, which we talked about last time. So we track the lineage of AI pipelines and the metrics and how, and figure out what data is leading to good outcomes, what data is leading to bad outcomes, which data is possibly more valuable, what are the things that you could do with it that will give you the better paths. And this framework that we're calling, this intelligence layer, is called the Data Foundation. So at the heart of it is this metadata tracking layer, which we call the Common Metadata Framework. At the north of it is these components called northbound intelligence, which help you optimize these AI pipelines using that metadata. And at the south of it is using the same metadata, but to go back and optimize the infrastructure and storage underneath.
And how is it implemented? How do you use it? Is it the library that other tools and components on top of it and below and input output can use it? How does it work?
Yeah, the CMF is exposed as a library. We also are making hooks so that it can be automated and called from certain frameworks. So there could be higher level things on top so that it becomes more automatic. And then you could have these interfaces, like with, say, for example, if you want to do storage tiering, then we would provide those markers and metadata to the storage layer and be able to call that. And likewise, there would be these optimization functions or libraries that applications can call. In addition, we also have this other project called Data Map, which is feeding this lineage information into a catalog. And so the way you use that, you're not really trying to program anything, but you're trying to use it by going and querying the catalog for data. And it gives you outputs where it is suggesting data sets to you. And so you can also use it from a more end user perspective, or you could use it internally using the libraries.
So what are some examples of the uses? Are those when you are suspicious about whether your data is correct one, or is it to manage the data? I mean, exposing metadata, it's like knowing everything about the data. Mm-hmm. Once you know about the data, what do you do about it?
So maybe each of these use cases is very different. Like say if I say an outbound application, one example is active learning. So maybe I have a lot of data and I'm trying to build a model out of it, but labeling is very expensive to do. Mm-hmm. Labeling means saying that this piece of data, represents this object or this situation. That is an expensive step in terms of effort. So what we can do is, because we are tracking which ones, as we are labeling samples and we are using them to train models, we can see if there is a new data, is it really adding extra value or not? And we can use that to figure out, what else needs to be labeled. So that's kind of an example of the northbound optimization case. It's particularly useful, for example, in AI for science use cases where sometimes you are generating lots of data through simulation. And simulation data is expensive to generate, labeling is expensive, requires scientists' time, and you can reduce that. Another example maybe in terms of what we call the southbound optimization. So maybe I'm doing deep learning training, and usually if you have a huge amount of data, training can take a lot of time, and it could also require a huge amount of I/O bandwidth. So we are looking at how you can actually, by observing which data is influencing the model as it is getting trained, which parts of the data are maybe more valuable and are very useful for you, and which parts are less. And that system can automatically then optimize the training time without losing accuracy, or optimize how you load the data from storage for each epoch that you train on. Do you keep learning from the same data for a few times before you go to the rest of the data, or do you keep circulating through the entire data all at once, which will be very expensive in terms of the storage and data movement costs. So we may be able to make those kinds of trade-offs automatically.
I wish I had that automated learning while I was a student. Because you expose metadata, does it make use of that data, like AI use of that data, more trustworthy?
Yes, that was actually one of the motivations for this. Because if you want an AI model to be trustworthy, you need the data to be trustworthy, you need the pipeline to be trustworthy. So you need this end-to-end thing to be trustworthy. For example, let's say, think of bias. So if you have bias data, you're likely to get a biased model. But sometimes you might be lucky that your pipeline is such that it is reducing bias, and your model is such that it is actually mitigating bias. That's great. But it could be the other way around. You might have a very little bit of bias, but somehow this model zeroes in on it, or the pipeline actually makes it more biased. Maybe it cleans out the data and actually leaves you even a bigger bias in that. These kinds of things, like a bias amplification, mitigation, can be automatically figured out by the data foundation. And then once you know that, then you can take actions to optimize that loop.
Very interesting, very interesting. So how are you going to deliver this data foundation? Are you contributing to open source? How are others going to use it? Is it only going to be HP's tool, or?
We actually have an open source project called the Common Metadata Framework. So that central layer that I was talking about, the idea was this metadata should be as easy as it is working with Git for code. So every time you work on AI pipeline, your metadata gets tracked, that gets committed, and then just like it gets pushed back. Somebody else can go clone the metadata and use it. So we have an open source project from it. It's early, and we are slowly we are building some of these intelligence components ourselves, and we are hoping that we can get a little more community effort around it, where people could try it out and, maybe figure out how to use slices of data and build trustworthy AI models based on those slices of data and things like that.
So let me see if I understood the business model. You open source it for broader adoption, but then you can do these intelligent plugins, differentiators that can provide competitive advantage for anyone using it. Is that right, or
yes.
did I get it wrong?
Yes, so then depends on which use case. If you're looking at a southbound use case, for example, from an infrastructure point of view, we can then use the metadata to be able to optimize the infrastructure. So that optimization is kind of specific to, to that use case. Or like what we said with Project Data Map, like we can use the metadata to actually recommend, better data, and that's part of that application, which is really providing that, that feature.
Publishing it as open source is probably the most convincing way for developers and the community. But do you do any other forms of publishing? Do you do, or is it conflicting with open source to do patents, publications? How does that work for you?
No, there's no conflict. So we have patented some of them, some of these techniques, and we have also published a few papers. So there's quite a bit of IP that we've had in this area. And we've published papers in the AI for Science community, for example. We did a paper at SMC 2022 on the Data Foundation, showing how it can be used for AI for Science use cases. We've published specifically on each of these techniques. So when I was talking about data valuation, so we have a bunch of publications. In fact, we work with a university collaborator on some of the publications in that data subset selection and data valuation area. So yeah, open source publication, patents, presenting to various communities. So we've presented to, as I said, the scientific community. We've presented to the Open Lineage community, or the LFAI, Trustworthy AI community. So that's another way for us to get feedback and on our work.
And it all rolled up to your promotion to HP Fellow and VP, obviously. I mean, putting so much effort, contributions, and congratulations for these papers and other artifacts.
But there is still a long way to go, right? I mean, I feel like we have just scratched the surface, and actually very excited about what else can we do with it, and there's a long way to go.
Last time when we were sitting remotely from India over Zoom, you were elevated to IEEE Fellow, and IEEE's tagline is advancing technology for the benefits of humanity. How does your work contribute to humanity?
So one of the big motivators especially for this Project Data Map, was really the Tech for Good initiatives that HP was involved in, because anytime we have these large societal problems, whether it's in the area of agriculture or healthcare or sustainability, as everybody's talking about, the main problem is connecting the dots between all the data and then making sense of it. And then, so AI models give us the techniques to do that. So if we can use AI for solving these problems, why can't we use AI for solving the approach of getting the data to solve those problems? And that's kind of what we are trying to address. So I think that was actually maybe one of the more satisfying parts of working on something like this.
Nice. HP really cares about diversity, equity, and inclusion. It appears to me that when you have lots of data, it's hard to understand what's going on. When you elevate it to metadata, it's much easier to recognize. Is that the way of thinking how your work with Data Foundation, metadata exposure contributes to DEI, or there are other ways?
So the example that I talked about bias, I think working on AI somehow made me look at bias and inclusion in a very different way, right? Because it's not anybody's fault, right? It's just that if you do not have the representative data, then it can lead to outcomes that are not fair to somebody. Or if you are somehow accidentally, like it's not just the data, but maybe somehow accidentally the model somehow fixates on some aspect of the data, that is really what is causing these kinds of bias. So I think our work on trustworthy AI is, helps us see what's going on, helps us explain what's going on. So this, in the case of the data foundation, the explainability goes back all the way to everything that's happened on the data that's being used to make these kinds of decisions. So I think that's, that is maybe one way that I think of it. I haven't thought about the angle that you're saying, that if I look at it at the metadata layer, it's true, maybe the metadata about the data is telling us the important characteristics that are relevant, but I haven't yet thought about it in that sense.
Okay, so you know that we usually end on a personal note, these podcasts. A lot of people haven't traveled a lot. I mean, we just came, my colleague and I, from Switzerland, and a lot of people told me over there, I haven't flown the plane, I don't even plan to fly the plane anymore. You just came across the ocean from India. How did your travel go?
Yeah, it was fine. It was a 16-hour flight. It's an 18-hour flight going back. But yeah, I think it's a long flight, a really long flight. But
so back to normal, both for positives and negatives.
Yeah, but it's really nice to be back here in the Bay Area. I mean, I'm coming after 3 years, and so yeah.
If I remember correctly, one of your hobbies was reading books. Can you recommend one of the most recent ones?
I'm reading a book on how we learn, and it's actually a book for, I think there are multiple books called How We Learn, but this one book is actually by a person who is actually kind of advising what you could do for education and helping in education. And it's interesting that this book is, it's very interesting for me because it is giving examples of how AI training works, but then connecting it back to what is really happening when humans are learning. The fact that we are not coming with a blank slate. We do have some things which are already well established and well trained, kind of maybe like our foundational models in AI. And then there are parts which are being adapted there. What is plastic, what is not. It's a pretty interesting book, and they have actually put these probes on young children to really observe which parts of the brain light up as they do certain things to really validate that research.
So left or right.
It's pretty interesting, yeah.
And then the last thing, if I remember correctly, your husband is running marathons. Have you followed him to some of the most recent marathons?
Actually, when I was on my way to the US, he was just in Mumbai, and he was running the Mumbai Marathon. He was a pacer for the Mumbai Marathon, so I think maybe he's done more now, over 50 marathons now. So yeah, he's pretty happy running.
Well, thank you very much for stopping by. I'm sure you had a very busy schedule as a newly minted HP Fellow and VP, so thanks for sharing with our audience.
Yeah, thank you very much. Yeah.